The first problem starts off with you got to be able to break down 72. Ideally, you would recognize that 72 is 2 times 36, and that 36 is 6 times 6, and those would come out. And so you would get 6, and then you'd have the 2 left over in the square root. Okay? Now, some people will break down 72 different ways. Some people will say 8 times 9, and then they do 3 times 3. That's fine. I mean, you can pull the 3's out like that, but you still have to break down the 8. I see a lot of people who will go 3 square roots of 8, and then they'll leave it alone. You can't do that because 8 continues to break down. Okay? So that's 4 times 2, which is 2 times 2. Ultimately, you still ought to get, anytime you have numbers on the outside, they all multiply. Ultimately, you ought to get back down to 6 square roots of 2, which is where you see us getting to here. Okay? So that's number 1. Number 2, how about the x squared? What's the square root of the x squared? That's just going to be x. How do you get that? It's 2 divided by 2 is 1. The remainder is 0. So you don't put anything for that. Now, 5 divided by 2 is 2 with the remainder of 1. So 5, y to the 5th is y squared, and then you'll have 1y left over on the inside. Remembering that the remainder always goes to the inside. Whatever the whole number was out front goes out front here. Okay. The biggest thing I see there is I see people who get those confused. And they'll do 6x. They'll put the y out here and then put the y squared on the inside. Yeah, you can't do that. All right. That's the answer to your first question.
So when you do the 5 divided by 2, that's basically the square root, the 5
Yep.
we have in there divided by the square root.
Yep.
82.
It's 2 because it, ish. It's 5 divided by 2 because that's your index.
Right.
If this were a 3, you'd be doing 5 divided by 3. Okay. Always takes hope. Gotta believe. All right. Cube root, negative 27. We're going to raise this to the second. Now, a lot of people let that negative do crazy things with them. Don't. The cube root of negative 27 is negative 3. Negative 3 squared is positive 9. The number 1 wrong answer I see, if this were Family Feud, it'd be, the number 1 answer is 1/9. I see people who see that negative and just want to force it to the bottom because they see a negative. Not really understanding where the negative is when it gets forced to the bottom, but they just see a negative somewhere and they're like, oh, hell with it, I'm pushing it to the bottom. I wish that were the case. I'd spend money like a madman. My account would be like negative 100. I'd be like this, make it a fraction. We good. No, you can't do that. Okay? So, negative 3 squared, negative 3 times negative 3 is positive 9. That's your answer. There was a question on that?
No, you answered it while you were talking.
Perfect. Ah, this one. Michael, you say this one's not so bad?
Huh?
You said this wasn't so bad?
It don't look so bad after you did the second one. Knowing that I got the second one right.
Okay. So what are you thinking you want to do? For those of you that don't know, this is Michael talking. Okay, go ahead, Michael.
I think pretty much we'll do the same thing that you did with number 2. Like do
So do the same thing as we did with number 2. I'm just saying it so people can hear you at home. The bottom part's not going to change any, at least for right now. What's the top going to be? So here's the question. Is it going to be A, x to the 8/3, or is it going to be B, x to the 16/9? A or B? I got 2 people who said A, and a lot of people who are abstaining. It is A. It is A. Not that. So this is going to be x to the 8/3. Now, why is that? Because you're multiplying it. It's an exponent being raised to an exponent. Those have to multiply. 4/3 times 2 over 1. 4 times 2 is 8. 3 times 1 is 3. It's 8/3. Now, what do you do when you have exponents over exponents?
Subtract.
You guys, JD's like a man on a mission today.
Dude, I got it.
11/4 minus 8/3. Do you have that, or do I need to take care of it?
Yeah.
What'd you get?
Then I got 32 over 12 minus 33 over 12.
And you
But
got
that's-
negative
I got negative
1 over 12, which caused you to move that x to the bottom, yes?
Yes, sir.
Now, for those of you that struggle with fractions, a little trick that you can employ, 3 times 11, multiply this way, 33. 4 times 8, multiply this way, 32. 4 times 3, 12. 1/12. Okay. What's wrong? Well, then find a common denominator.
Well, is only the numerator being multiplied?
Yeah, I
Can I ask you a question?
On top?
Yeah.
Yes. Yeah, it's 4 over 3 times 2 over 1. You don't need to find a common denominator for that. It's not multiplication. It's not addition, subtraction. So yes, you're just multiplying the 4 times 2 to 3 times 1.
Okay.
Yes.
My other question is, can I cancel out the 4 and the 8 to 1 and 2, or it messes it up?
Okay, great question. So the question is, when you have x to the 11/4 and 8/3, 8/3 and 11/4, she wants to cancel the 4 here and the 8 here. And the answer is no, you cannot do that.
Multiply 'em.
We're not multiplying them. We're subtracting. We're doing 8/3 minus 11/4, or 11/4 minus 8/3. So no, you cannot cancel those.
So, okay. After you get the x 8 over 3rd over x over 11, what do you gotta do?
You gotta subtract. No, you gotta subtract. Just like when you had x to the 8th over x to the 2nd, you went x to the 8 minus 2. You subtracted the exponents. You just gotta subtract the exponents. I subtracted the 11/4 minus the 8/3 because this number is bigger than this number is. Okay, but you just have to subtract, and it's just fractions, so it's a little bit harder.
I see it.
I'm gonna say it's harder. It's not harder, but students view it as being harder because it's fractions. There's a segment of the population that just won't do it because it's fractions. You know, they just skip it and go to the 4th one. I'm not saying anybody, you know. All right. So let's just skip it. We'll just move on to the 4th one then. Seems like a good idea. So, here, when you do this, you're looking to make sure that these two pieces are the same. And if they're not the same, then you should work on trying to make them the same. So 32 is 2 times 16. 16 is 4 times 4. The 4 comes out. Now, here's the question. When the 4 comes out, it's going to join with what's out here. I hope everybody knows that it doesn't become 54. Or 45. Like, I hope you know you don't take the 4 and go, oh, gee, look, that's 45. No, it's not that. But here's the more important question. Is it 9 square roots of 2, or is it 20 square roots of 2?
20.
20.
It is 20.
Is this a 4?
You're going to multiply the 4 when it comes out. It's going to be 4 times 5, and you're going to get 20 square roots of 2. I do see a lot of people who want to add those or subtract them, and you don't do that. Okay. Once you do this, what do you get?
Negative 19 square root of 2.
Negative 19 square roots of 2. Why do you get negative 19?
You gotta subtract the 1 from the 20 invisible.
There's an invisible 1 there in front. 1 minus 20 is negative 19 square roots of 2.
Where's the invisible one?
Right in front of the square root of 2.
Okay.
I think there should be a whole class lesson at some point in your life on where the invisible 1 shows up. Because it kind of shows up whenever teachers need it. Like whenever I need it, there's a 1 there. For students, it never shows up when they need it. Like,
We're still fine.
it never seems to just mysteriously appear when students need it. But for teachers, we're always like, oh, there's a 1. Bam. And
Number 3, yeah.
sure.
Oh, because that's a negative 20.
Oh, I didn't say anything.
That's a negative 20. That's why it's a negative 19. Okay.
Yeah.
I'm sorry.
Lastly, this one. This one is off the chart, so if you didn't get this, don't worry about it. We didn't do it last time. So, probably somebody only of JD stature might be able to do this one.
That's right.
50 is 25 times 2. 25 is 5 times 5. Jay, did you do that?
Yes, I did.
And you got 5 squared, it's 2x.
Yes, sir.
All right, good shot. And then you wrote down the 8.
Yes, sir.
And you got 4 times 2.
No, yeah.
And then you got 2, you got a square root of 2 there, right?
No, I got 2x.
Okay, so you got 2x square root of
2x.
2x. Now what'd you do?
I left it because they're not like terms.
Ah, very nice, JD. JD left it. I was convinced, JD, you were going to say 7x. I just knew.
They're not like terms, though.
Yeah, I know, but that doesn't stop people from doing it. I mean, some people go like this. Oh, damn, I'm going to raise that shit. 'Cause I know it ain't right. What were y'all thinking? You're right. They're not like terms, right? So this and this are not like terms. So you cannot add them together. But what can we do? We can factor out this piece. And so that's what I'm going to do. I'm going to take out the square root of 2x. What am I going to be left with?
Oh.
5 plus 2x.
Oh,
Now, when you look in the back of the book, you won't see this answer. The back of the book will tend to do something like this. They're going to use the commutative property and say 5 plus 2x square root of 2x. They're going to take that square root of 2x and move it to the back side. It's the same thing. Okay? For people who are just starting out, that's a very hard thing to do, because when I say factor out the square root of 2x, you think of factoring out meaning move it to the front. Most people don't think of factoring out meaning put it at the end. And so when you look at the answer in the back of the book, you can see it at the end and you're thinking, why the heck did they put it down there? It's just a matter of convention. Okay. Any questions on that? All right.